Hey guys, welcome to the solutions for the similarities in triangles test. Let's get right down to it. What I'll do is, since all the tests are in, I'll let you guys see what you did wrong. After I make this video, I'll just put where you can see your mistakes, and then go ahead and correct them. I'll get you those points, those partial points back if you make good corrections and tell me what you did wrong. Okay, let's take a look. Here we go. Now, these aren't going to be in any particular order because they're all randomly arranged. So you just have to figure out where you did these problems in what order. It says if two triangles are similar, then their corresponding angles will be, then their corresponding sides will be congruent. And so obviously that is not true. It will not be the sides. Their corresponding angles will be congruent. Their corresponding sides will be proportional. So I think that's what I wanted. It was a false, plus you had to add that they would be proportional. So that's how you get full points for that one right there. All right, so the next one is, are these two triangles similar? Well, we can't do angle-angle similarity theorem because there's only one set of angles. But that's good. We do have sides that sandwich that angle, so it could be a possibility for SAS. But we remember, it's not the sides are congruent, the sides are proportional. So when I go through, I get 5 over 15, which is 1/3 or 0.3 repeating. And then when I put the yellow ones as a proportion, I get 18.3 over 54.9. And that actually also turns out to be 0.3 repeating. So they are definitely similar because it's SAS, because we have a side, the blue sides, we have the angle, the green angle, and we have the yellow sides that are proportional. So the answer here would be true. Okay. All right. Next one. We want to know what the measure of C to B is. Well, the first thing we need to know is that these two triangles are similar. And we know that they're similar because these points right here, we can say because these lines are parallel, these two corresponding angles are congruent. And if corresponding angles are congruent, then lines are parallel. So now what we have is we have this reflexive angle that both the little and the big triangle share. So now we can use angle-angle similarity theorem. We have the big mama triangle and the little baby triangle, and they're similar to each other because of angle-angle similarity theorem. So we can just say, hey, we want to find CB. Well, let's call that X. So we can say, okay, let's start with the little triangle. 6 over 13. So 6 little triangle side to little triangle base equals 14. Now, how did I get 14? I just added up 6 and 8 and got 14 over X. So what I did, I chose to do little side of triangle to little base of triangle, big side of triangle to big base of triangle. And CB is just the big base of the triangle. Now I just cross multiplied. So 6 times X, I did the butterfly, right? I butterflied this problem. 6 times X and 13 times 14 is 182. And then I just divided both sides by 6, and I came up with approximately 30.3, and it wanted you to round to the tenths place, so one place to the right of the decimal. Okay? All right, let's take a look at the next problem. The next problem is the geometric mean of 24 and 16 8 square roots of 6? Well, these are the extremes, right? So those extremes are going to go right there. And then to find the geometric mean, we just put an X down here and an X right here. These are the means of a proportion, and these are the extremes of a proportion. So a proportion always has two means and two extremes. Now remember, so that's a bad E right there. When the means are the same, when we know the mean is equal to each other, then we call it the geometric mean. So then we just cross multiply. So X times X is X squared. And then I didn't actually multiply out the 24 times 16 because I know that 24 is actually 6 times 4. So instead of multiplying it out, I actually factored it out more as 16 times 4 times 6. So the square root of 16 times the square root of 4 times the square root of 6. Well, square root of 16 is 4. Square root of 4 is 2, and square root of 6 is just the square root of 6. So now I get 4 times 2, which gives me 8. So I get 8 square roots of 6. So that would be a true statement there. Okay? All right. Next problem. This one, you need to find x. We're involving the hypotenuse, so we want to use that first theorem. The first theorem says little side to the altitude, O equals the altitude to the other side, right? Side, little triangle side to altitude to the altitude to the other little triangle side. So x over 2 equals 2 over 4. X over 2 equals 2 over 4. That's what I set up in that proportion right there. And then I just cross multiplied and got 4x equals 4, divided both sides by 4 and got x equals 1. Now I'm not done yet because I'm trying to figure out AC. I'm trying to find the measure of AC, which is all the way across. So this is 1 and this is 4. 1 plus 4 is obviously 5. So that was the number you needed to put in there, 5. Okay? All right. Next one. If two triangles are right triangles, then they're always similar to each other. Well, no way. We just talked about this. I'm hoping that we all saw that. That's an absolutely false statement. We've just talked about two different kinds of right triangles. We have special rules for each one of them, the 30-60-90 and the 45-45-90. Those are both right triangles, but they are absolutely not similar because you can see their corresponding angles are not congruent to each other. Therefore, you can have lots of different kind of right triangles that aren't similar. Just because they're right triangles does not mean they're similar triangles. Okay, so that was kind of a little making sure you understand that concept. All right, so this one was a tricky one. I actually had to kind of look at it for a minute or two. Let me get rid of my picture here. So here's what's happening here. So the shadow, the sun is up here, okay? This is a purple sun. I don't know, and it's shining here. So this tree shadow, this is the tree shadow right here, okay? This little dude's shadow is right here. So that's the first thing you got to be careful about. So the tree shadow is equal to 39.55. Now the dude's shadow is not 34.1, it's 39.55 minus 34.1. Okay? And so the dude's shadow, I don't know, Jai, is that his name? The dude's shadow is 39.55 minus 34.1. So I got the dude's shadow to be 5.45. Okay? And so now what I want to figure out is the height of the tree. So this is the dude's height right here, 1.45. And that corresponds to the tree's height. I don't know how tall the tree is. So this is the dude. This is the tree. But I do know that then I go back to the dude. His shadow this is the dude's shadow. And that's 5.45, which I just figured out. And then I know the entire shadow of the tree is 39.55. So, and then it's just a proportion, guys. You're just going to butterfly it, right? So x times 5.45 is 5.45x. And then I multiplied, and then I need to multiply 39.55 times 1.45. And I just do the math and just grind it through using algebra. You could have used a calculator on this, so don't. And then I said calculators are fine on this. And then you grind it down to about x is approximately equal to 10.52. And remember, guys, it wanted you to run to nearest hundredth of a meter. So 2 places to the right of the decimal. So 10.52 would be the answer on this problem. That was probably the most challenging one in my opinion, because you kind of had to see what was going on and read. I had to read it a couple times first before I got that. All right, so are these triangles similar? Well, we don't have any angle information on these triangles, so the only possibility we could say is SSS true. Well, obviously they're not, the sides aren't congruent to each other, but when I put them into fractions and change them, in this case, into decimals, am I going to get the same number every time? And the answer is no. These are 3 different numbers I have here, and so they are no. This fails SSS, so this would be no. This is false. Okay, they are not similar because these yellow and green and blue fractions are not equal to each other. They would have to all equal the same thing. Instead of reducing, I just changed them to decimals. That's kind of the same deal. All right. This one right here, Cecile's solution is correct. Amelia just wrote the wrong proportion. What did Amelia did? She did 8 over EF, 8 over EF. So she did, so what did she do? She did side over hypotenuse equals hypotenuse. Oh, she should have said, instead of saying hypotenuse over 4, she should have said hypotenuse over she should have said over 12 would have worked, but she did over 4. She did EF over 4. So this should have been a 12. If hers would have worked, it should have been a 12. Now, Cecile's was right because she went 12. So she went big hypotenuse over big side, and then she went little hypotenuse over little side. This is kind of just like opposite of what we're used to, but yeah, this one looks good. So Amelia used the wrong proportion on this problem. Okay. All right. This one right here, I just went through and I put what NO is equal to 20, NP is equal to 15, OL is equal to 15, NP is equal to 12, and I want to find PM. Now, what I'm noticing is I can use the side splitter theorem because I know these lines are parallel. And why do I know those two lines are parallel? Because the corresponding angles are congruent. So you can only use the side splitter theorem if you know those two sides are parallel, which they are. Therefore, the side splitter theorem says this part over this part equals this part over this part. And so I just write the proportion, do the math, and I get x equals 9. So if you just want to look over my work here and just see it's just some algebra solving, and I get x equals 9 on that. All right, if two triangles are congruent, then they are similar. Well, yes, if two triangles are congruent, then automatically, because of CPCTC, all the parts are congruent, all the angles are congruent, and all the sides are congruent. But we don't really even care about the sides as much. We want to talk about the angles. If they're congruent, which means their angles are congruent, which means all the corresponding angles would be congruent. And that's one way we can show two triangles are similar, by showing their corresponding angles are congruent. All right, next one. I don't know why this is saying true right here. It shouldn't. I don't know. I clicked on it. The geometric mean of 18 and 3 is 6 square roots of 3. Well, again, it gives the extremes, which is 18 and 3. We have to find the geometric mean, which is x and x. We get x squared equals 18 times 3. I factored 18 out into 9 times 2. So 18 times 3, when I take the square root of both sides, is the square root of 9 times the square root of 2 times the square root of 3. Square root of 9 is 3, and 2 times the square root of 2 times the square root of 3 is the square root of 6. So we get 3 square roots of 6 is correct. So 3 square roots of 6 is the answer, which is false because they said it was going to be 6 square roots of 3. So it's false. What I did is just kind of switched it and make sure you were paying attention there. So it should be 3 square roots of 6, not 6 square roots of 3 on that one. All right, what's this one? We want to find x. So we would just do, okay, so what did we do here? We did 3 little side over little hypotenuse equals hypotenuse over big side over big hypotenuse. So 3 over 6 equals 6 over x. And then I just cross multiplied and got 3x equals 36, divided and got x equals 12 on that one. Let's look at the next one. Okay, this one we want to find x. So this is little triangle. Whenever you're using the altitude, you want to use the first theorem. So it's x over 4 equals 4 over 2. And then you just cross multiply. You get 16. 4 times 4 is 16. X times 2 is 2x. And you get x equals 8. 8 for your final answer. And that looks like it's it, guys. I think I did all the problems there. Hopefully this helped you get some points back on your test. Get them back to me by Friday. You can email them to me or get them to me as a hard copy. We'll see you later. Bye.